And so then we talk about the composition of bone. We talk about the inorganic parts and the organic parts. So the inorganic things are going to be hydroxyapatites, or mineral cells. About 65% of the mass of the bones is going to be the inorganic material. And it's going to be mostly calcium in the form of calcium phosphates. And it's responsible for the bone hardness and its resistance to compression. So osteogenesis and ossification basically are going to be formation of bone. When we're talking about bone formation, those are the words we use, osteogenesis or ossification. And it's the bone tissue formation. And what happens is in the embryo and the fetus you have cartilage, and that cartilage turns into bone. And we'll be talking about how the bone develops into, the cartilage develops into bone. So it forms the bony skeleton in the embryo, and then bone growth until early adulthood. Because once the epiphyseal plates fuse in adulthood, then the bone growth is a different form. And also it does bone thickness, remodeling, and repair. So if you have a fracture, certain parts of the bone are going to be built up, other parts may be torn down. And bone starts out as cartilage and fibrous membranes, and then it changes to bone. So when we're talking about the epiphyseal plate, remember that's a cartilage disc that's in the bone, and that cartilage becomes bone. And certain areas that need to be more flexible are going to remain as cartilage. For example, if you have your ribs, remember we talked about the ribs where you have the bony part of the rib and then it junctions into cartilage as it comes more towards the sternum. So your rib cage has a little bit more flexibility, for example, than your humerus, your femur, things like that. And then parts of your nose are going to be more elastic cartilage, your ear, things like that. So the formation of the bony skeleton begins about the 8th week of the development of the embryo. And it's intramembranous ossification, meaning that it forms inside from a membrane. And it starts out as fibrous tissue, and then it's eventually going to develop into bone. And then you have endochondral ossification, meaning that the bone is formed from cartilage. If you look at a fetus, it starts out as hyaline cartilage. Most of that cartilage is going to be turned into bone, and some of it's going to remain as cartilage. And intramembranous is the way that most of the flat bones of the skull and the clavicles are formed. And so you have the fibrous connective tissue membranes on the outside, and then it develops into bone. So now we'll talk about the stages of intramembranous ossification. So first you have the fibrous connective tissue, and then inside of that you have a ossification center. So it starts ossifying at one particular spot, and then it spreads its way out. And then the bone matrix is secreted within the fibrous membrane. And then you start getting the periosteum that's going to form, and different parts of the bone. And then also, if you have compact bone, parts of the compact bone that are going to be spongy bone are formed by this method. And then you're going to start getting the red bone marrow. And that's, remember the red bone marrow, that's going to be the tissue that forms the blood cells. And now we're talking about endochondral. So by the name of endochondral, there's types of bone that's formed from within cartilage. So in the first case, we're talking about intramembranous, that's formed by a membrane, and that's going to be your flat bones, things like that, where you have endochondral ossification, and that's going to start in the 2nd month of development. And then the hyaline cartilage are going to become bones. So the hyaline cartilage sort of sets up the framework of where the bone's going to become, where it's going to turn into bone. So what happens is that hyaline cartilage has to get broken down, before it gets replaced with bone. So the different stages, let's see, we'll have the pictures here. So you're going to have this hyaline cartilage that's going to start out here. You have this ossification center, and then it's going to work its way out. And then it's also going to start in the epiphysis. And then those are going to meet in the middle. And then once this bone is formed, the way that the long bone grows, like I mentioned here, is at the metaphysis, or the epiphyseal plate. So you have the bone collar, and then the cavitation of the hyaline cartilage. And then basically the periosteum starts in that internal part, like on the other picture we saw, and it starts forming spongy bone. And then as it's working its way out, the peripheral of it is going to form the compact bone. And then also you're going to have the medullary cavity, and then you're going to have secondary sites of ossification at the epiphysis. So it starts out, if you have a long bone here, it's going to start out in the middle, and then you're going to have the two epiphyseal areas where you have the secondary locations of ossification. And then, like I mentioned, is that epiphyseal plate is going to remain cartilage during the growing years. Because once you start growing, once the skeleton's formed, the way that it grows is at the epiphyseal plate. So again, here, it's starting in the center here. You start forming the spongy bone, and you can see the artery there is going into the middle of it. And then you start getting the compact bone formed around the outside. And then later on, you start with these epiphyseal areas of secondary growth. And then here, this membrane stays as cartilage, and that's where the long bones grows in the developing adolescence. I mean, I realize that some of this stuff is, pretty detailed, and it may be more than you need to know in the long run. As far as we're going to focus more on the anatomy and landmarks and things like that. So a lot of this stuff is background information, and you want to make sure that you know the basic things like what's the periosteum, what are osteocytes, osteoblasts, things like that. And you don't need to necessarily know all the details of this bone formation and things like that. Just understand the general concepts. You need to know that there's an epiphyseal plate, and that bones develop in the fetus, they turn into bone, and then you have the epiphyseal plates, and that's how they grow in adolescence. And then when you become an adult, the epiphyseal plates close. As far as getting into a lot of this detail, don't worry so much about memorizing all of it. Okay? Focus more on the basic parts of the beginning part of what we talked about, rather than all these details. But just you need to understand that there's a difference between long bones and flat bones in the way they're formed. The flat bones are formed by intramembranous ossification, and then the long bones are formed from cartilage. As far as each one of these individual steps, this is more just for background information. So then we get into the shapes of the bone. So we're going to have flat bones. Right? These are going to be things like the sternum, the bones of the skull. And those are going to be intramembranous formation. Then you're going to have the long bones. Right? And how are long bones formed? What kind of bone formation do they form? They come from cartilage as opposed to from membranes. Right? And then what kind of marrow cavities do they have? Is it going to be red bone marrow or yellow bone marrow? Right? So sometimes when I'm talking about different things here, I mean, I'm kind of a foodie person, so I relate things to food. I mean, some people, if you go to fancy restaurants and they serve bone marrow, right? Heard of that? What that is the yellow bone marrow. They take long bones and they slice it up like that, and you have these little fancy spoons and you spread it on bread. So that's going to be the fatty bone marrow, the yellow bone marrow. Okay? So that's in the long bone. Okay, so then in long bone,